Section 4.2, one-to-one functions and inverse functions. What are one-to-one functions? Well, recall that we already looked at what is a function. And in order for something to be a function, every x value has to map to exactly one y value. Well, a one-to-one function is not only does every x have to map to exactly one y value, but also vice versa. So two different inputs in the domain correspond to two different outputs in the range. And you can go ahead and finish reading that definition. Let's look at an example. It's always easier to see a definition when you actually see an example. In A, I wrote down a few professions: a professor, physician, and a fast food cashier. And for the range, I have their hourly wage, $60, $12, and $100. Now, notice that professor, think of these as the x values, maps to only one y value, 60. But it's also true the other way around. So the fact that professor only maps to one y value or one value in the range is a function, but the fact that 60 also only maps to one person is a one-to-one. So for example, let's say that I had that professors make $60 an hour, but also physicians make $60 an hour. So this here is still a function, but it is no longer one-to-one because the 60 is mapping to two different professions. Okay. So in this case, the function is one-to-one. For every domain, there's exactly one range and vice versa. Now let's look at the graph. What do you think? Is this one-to-one? Well, before we answer that question, I do want to remind you that this is a function because this passes the vertical line test. In other words, if I take a vertical line, it only crosses the vertical line at exactly one point. To check if this is one-to-one, we can actually do something that's called the horizontal line test. So if we pass a horizontal line and it only touches the horizontal line once, then it is one-to-one. So notice this horizontal line that I drew here actually crosses my graph 3 times, and therefore this is not one-to-one. And the reason being is because one y value, mainly what is that, negative 0.1? Negative 0.1 maps to 3 different x values. So as you can see, this is not one-to-one. So I wrote here the short explanation. You can go ahead and pause that and read it slowly. Okay, and then again, I'm just reminding you that the vertical line test tests if a graph is a function, and the horizontal line test tests whether the function is one-to-one or not. Let's move on to inverse functions. Now, the reason one-to-one functions are special and it's important to study them is because one-to-one functions have inverse functions. And then you're going to see why inverse functions are important. Okay, so what is an inverse function? Well, by the way we write inverse functions is f to the negative 1, which is it's not a power, it's just the way that we write our notation for inverse functions. Okay, so f of negative 1 of x. The x values, okay, so now I'm reading in my bullet points. The x values of f of x are the blank values of n inverse of x. So what happens with the inverse functions? Well, an inverse function is symmetric about the line y equals x, which means that if you have an x value in f of x, then this x value is now going to become your y value in the graph f inverse of x. If you have a y value, this y value in f of x is now going to become an x value. I'll draw a graph right now to show you what I mean. the domain of f of x then, so if the x is in the y switch, the domain of f of x is now the range of f inverse of x. And the range of f of x is now the domain of f inverse of x. And this really comes in handy when you have functions it's really complicated to graph the range or to find the range algebraically of a function. But if you can find its inverse and we find the domain of the inverse, we know that that's the range of the function. The reflection of the graph of f of x about the line y equals x is the graph of f inverse of x. For example, if f of x contains a 0.32, then f inverse of x contains the 0.23. And I think I'm going to sketch a quick little graph here on the side so you can see what the f function and the f inverse function actually look like if we were to graph them. And I'm just going to draw the line y equals x because we know that inverse functions are symmetric about the line y equals x. So we're going to dot that since that's not really part of our graph. Okay. And I think I'm going to do f of x in red. And we'll do a simple one right now. Let's say you had, I don't know, let's say you had this graph, okay? And let's just say that this is the point -2, 0. And let's say this is the point 0, 1. Okay, now, if you want to draw the inverse function, then we know, and let's go ahead and label this as f of x. So if we want to draw the inverse function, then we know the inverse function has the point 1, 0, since the function has the point 0, 1. So now we're at 1, 0. Okay. And we also know that the inverse function has the point 0, -2. So let's say it's somewhere over here. Okay. 0, -2. And then this is what our inverse function looks like. So notice that it reflects about the line y equals f of x. Okay. And then as you can see, the domain of f of x is -2. Actually, that would be a good practice. Let's do that. So the domain of f of x is equal to -2 to infinity. And the range of f inverse of x is also -2 to infinity, right? Okay. So then the range, and then it flips, right? So the range of f of x will now become the domain of f inverse of x. Okay. Note, if we do denote a function as f of x, then its inverse function is f inverse of x. And then I just wrote there, please keep in mind that f inverse of x does not equal to 1 over f of x, which again, as I said before, the little -1 is not a power. And then we'll go ahead and do example 1 in part 2.